All right, let's jump right in. Welcome to this explainer titled Exactly, NCP-MCI 7.5, 12.2, Replication Schedules, and RPO Tiers. We are tailoring this specifically for your Nutanix NCP-MCI 7.5 certification prep. So whether you're spinning up your very first Nutanix cluster or you're a seasoned infrastructure admin getting ready to crush that exam, nailing down data protection is, well, it's non-negotiable. We're going to break down exactly how Nutanix handles replication to keep your critical workloads totally secure.
Here's our game plan for today. We'll kick things off with why replication matters. Then we'll walk through the three main tiers: Asynchronous, NearSync, and Synchronous. After that, we're hitting the exam traps and edge cases. And finally, we'll wrap up with the key facts you absolutely have to memorize.
Okay, Section 1. Why replication matters? Foundations of disaster recovery. So the anchor for this entire topic is probably the most important acronym you're going to need: RPO, or Recovery Point Objective. Put simply, RPO defines exactly how much time's worth of data your company can actually afford to lose if everything goes south. Think about it. If your RPO is set to 1 hour, you are formally accepting that you might lose up to 59 minutes and 59 seconds of recent data. It's this fundamental business metric that essentially dictates every single aspect of your technical architecture.
Now, we configure these replication schedules for a couple of major reasons. Obviously, the first is to protect against the unplanned stuff, right? We're talking natural disasters, or maybe a severed fiber cable that just completely takes out your primary site. But honestly, just as importantly, these schedules facilitate planned events, like your scheduled weekend maintenance, so you can move workloads around without anyone even noticing. And here's the crucial takeaway. You always have to balance that resiliency with system overhead. The tighter your RPO, the more compute and network you're constantly burning through.
Moving on to Section 2, Asynchronous, 1 hour plus.
Starting at the top with the most lenient tier, asynchronous replication schedules require an RPO of 60 minutes or greater. Under the hood, this relies on your traditional incremental snapshots. You can set these to run in hours, days, weeks, or even months, depending entirely on what the workload actually needs. Because there's a relatively large gap between these replications, this tier is incredibly flexible. And the best part? It absolutely does not demand an ultra-low latency connection between your sites.
Let's ground this with a real-world example. Picture a basic internal file share or a standard web server cluster. Step 1. That server suffers a sudden hardware failure. Boom. Step 2. Because we're running asynchronous replication, we might lose up to an hour of data. But for a standard web server where the configurations are mostly static anyway, that's completely fine. It doesn't derail the business. And Step 3 shows us the why behind this choice: efficiency. Your network strain is kept to an absolute minimum. You're not just hammering your WAN links with real-time data, which keeps that bandwidth wide open for your more critical traffic.
All right, Section 3, NearSync, 1 to 15 minutes. So how does this compare to what we just talked about? Well, while NearSync is technically still asynchronous under the hood, it uses these highly optimized, super lightweight snapshot mechanics to shrink that protection window way down. Where asynchronous gives you an hour or more, NearSync aggressively tightens the gap, which fundamentally changes how fast your system has to process those incremental changes. It basically skips the heavy metadata overhead of traditional snapshots so it can hit those much shorter targets. To be specific, NearSync gives you an RPO strictly between 1 and 15 minutes. You're configuring this in granular minutes. This is your go-to for critical databases, those application servers where losing an hour of data would be a total disaster, but losing a few minutes, that's a calculated, tolerable business risk. It saves you from having to buy the massive physical infrastructure required for true real-time syncing.
And keep in mind, NearSync can replicate between 2 on-premises availability zones, or AZs. An AZ is just a distinct physical location inside a region built specifically to be isolated from failures. But here's the really cool part. NearSync is totally supported for disaster recovery into Nutanix cloud clusters, or NC2AZs. That gives you some seriously powerful hybrid cloud flexibility, letting you seamlessly bridge your on-prem gear with AWS or Azure.
Section 4, Synchronous, 0 RPO strictness.
0. Just 0. That is the magic number you need to burn into your brain for synchronous replication. It lets you protect your entities with a 0 RPO by replicating all your writes synchronously to the recovery AZ. What does that mean? It means before the primary application even gets a simple acknowledgement back saying, yep, data's written, that data has already been safely shipped and committed over at the recovery site. It is simultaneous, real-time protection.
But because it's real time, the exam is going to test you heavily on its strict requirements. First up, latency has to be virtually zero. Second, Nutanix explicitly mandates a redundant physical network between those clusters to handle peak write traffic safely. And third, this is a big one, for entities running on AHV, you can only perform disaster recovery to another AHV cluster. No mixing and matching hypervisors when you're demanding zero data loss.
Let's look a little closer at that latency piece. Round trip time, or RTT, is literally just the time it takes for a signal to travel over the physical cables from the source to the destination and back again. For synchronous replication, Nutanix requires that your RTT is under 5 milliseconds. This is absolutely critical. Why? Because any network latency directly slows down your primary storage write performance. If your network is slow, your application becomes slow because it's literally sitting there waiting for that remote confirmation before it can do anything else.
Let's look at another concrete example to see this in action. Step 1. You deploy a mission-critical Windows Server failover cluster, a WSFC. Because this demands zero data loss, Step 2 kicks in. Nutanix strongly recommends co-locating the owner VM with the primary storage for optimal performance. Step 3 is the underlying why. In a synchronous setup, the recovery storage basically acts like a transparent proxy layer, just forwarding I/O reads and writes back to the primary storage. This continuous dance of forwarding requests is exactly why you absolutely must have that robust sub-5 millisecond network, otherwise you're going to cause severe application lag. Okay, Section 5, Exam Traps and Edge Cases. Let's make sure you don't get tripped up.
All right, here is a classic exam trap. What happens if you try to set up multiple synchronous schedules in a multi-site AHV metro deployment? Just take a second and think about what would happen to your cluster overhead and your network saturation if you tried to force the system to sync everything everywhere all at the same time.
Well, the system actually prevents you from doing it. You are strictly restricted to configuring no more than one synchronous schedule per protection policy. Doing anything else would risk totally crushing your primary cluster's performance under the sheer weight of all those remote storage acknowledgments. Now, to keep things efficient, you absolutely can mix in asynchronous or NearSync schedules alongside it for your other VMs, but you only get one synchronous schedule per policy. So do not let a multiple-choice question trick you into thinking you can just have unlimited synchronous targets. No way.
And here is another massive gotcha you need to memorize. Synchronous recovery points are crash-consistent only. Even though the replication itself is instantaneous with 0 RPO, the policy automatically takes a snapshot recovery point exactly every 6 hours. Because this replication is happening way down at the bare metal physical storage level, it doesn't pause to reach up and talk to the guest OS. So these recovery points do not quiesce the file system. They are strictly crash-consistent.
Finally, Section 6, Key Facts to Memorize, the cheat sheet.
Seriously, take a screenshot of this table right now. This is your holy grail for this topic. Just to recap, asynchronous is 1 hour or more. NearSync is strictly 1 to 15 minutes. Both of those use incremental snapshots and can handle moderate network latency. But synchronous, that is exactly 0 seconds RPO, its automated recovery points are crash consistent only, and it absolutely demands under 5 milliseconds of RTT latency. Master the nuances in this matrix, and you're going to breeze through the replication questions.
So, as you head into your exam prep, I want to leave you with this to think about. Do you truly understand the intense physical network investments required to support a flawless 0 RPO environment? Because, it's one thing to confidently just select synchronous from a drop-down menu on your hypervisor. It is a completely different beast to practically architect a redundant sub-5 millisecond physical network that actually keeps it alive without bringing your whole business to a crawl. Think about that as you continue your studies. Thanks for hanging out with me on this explainer, and good luck crushing your NCP-MCI 7.5 exam.